As much as I have tried to put this subject down and not do anything more with it, something keeps popping up almost daily to drag me back into it again. For instance, today, October 27th, 2015, someone posted this pic on my wall, and it's a picture of the Denali Range from Kashwitna Lake, available on Wikipedia under the page for Mount Foraker. I'm not sure how you pronounce that. The distance from these peaks is listed as 100 miles. The curvature of a 3,959 mile radius sphere is just under 8 inches per mile squared and commonly accepted as the curvature of a spherical Earth. We simply plug in the numbers. 100 squared times 8 divided by 12 equals 6,666.7. There is supposedly 6,666.7 feet of curvature between the point of this photograph and the mountain range in view. If there was over 6,500 feet of curvature between the photo's point of origin and the mountain range, then Mount Hunter would have roughly 7,000 feet visible, and Denali would have roughly 13,000 feet visible. The curvature would make Mount Hunter appear roughly 53.5% the height of Denali. Creating straight lines from the horizon to the peak of each mountain, the measurements from smallest to largest show 141 pixels, 173 pixels, and 202 pixels. This shows Mount Hunter as exactly 70% and Mount Foraker as 85% the height of Denali. There is only one explanation for this discrepancy. Mount Hunter is actually 70% of the height of Denali, and there is no curvature. You can fact check all of these mathematical equations, heights and distances, measurements, and test them against any large mountain range you wish. The answer is always the same. There is no curvature. Somebody posted that on my wall today, got me thinking about it, and I'm just going to think out loud here. But on a ball, in addition to scaling problems, would not the very distant high mountain peaks have to be arching away from each other toward the left and right instead of appearing straight up and down? Seems to me this is a very good test. Distant mountains sitting on a ball would show all sorts of visual perspective issues, from scale to angle problems. Yet anytime I've ever seen a distant mountain range, it always looks like the mountain peaks are appropriately scaled and in a straight line, going out as far as the eye can see. The fact that the horizon never drops below eye level is also problematic for believers in the globe. The higher up you go, the more you should have to drop your line of sight downward in order to see the horizon. But this is never the case, even at altitudes above 60 miles. And I've got a video here, a little animation that I did showing like a hot air balloon going up over a very large ball or going up over a very large plane. And as it goes up over the plane, the horizon always stays the same. It stays at eye level. But if you were rising up over a ball, that would not be the case. The higher up you go, the more you should have to adjust your eyesight, your eye line, downward. You have to tilt your head to look down toward the horizon as the ball recedes away from you underneath you. And I say in this animation, so then the question is, which illustration best fits what we always see? And really, I mean, you see that that's the case even to altitudes up to 160 miles in some of these other videos I did here. I'm not going to play them here, but you can check them out for yourself. Well, actually, I'll play this one. This one's short. In my blog series at testingtheglobe.com, I've shown that the alleged curvature is not even detectable at 120,000 feet when people send up weather balloons with cameras not fitted with a fisheye lens. And by that I'm talking about, there's some videos that I have on my website there, and you can do videos yourself, do some searches on YouTube for videos of people doing high altitude weather balloon tests where they're sending up weather balloons. And if they have it fitted with a camera that doesn't use a fisheye lens, I mean, that thing is going up to 120, 121, 127,000 feet and spinning in 360 degrees and showing the horizon flat as a pancake, as opposed to the Red Bull video or, you know, typical NASA video, which is always, it seems like always shot with a fisheye lens. And that's easy to tell when they're using a fisheye lens. First of all, like in the Red Bull deal, when that dude gets out of the capsule and stands out and they cut to the camera outside looking at him, the curve of the Earth is so ridiculous. The size of the planet would have to be less than that of the moon. And that dude would have to be jumping from like millions of miles away, or at least hundreds of thousands of miles away. I mean, the curve is just insane. And whenever the camera tilts at certain angles, I mean, it goes from convex to flat to concave to flat to convex to you know, it's going all over. It's an incredible morphing Earth. That's what happens when you use a fisheye lens. And a lot of the cockpit footage that I've seen from like these Russian MiGs and stuff that people are sending me, that get up there really high, same thing. In fact, you can look in one of the shots over the pilot's shoulder there. The wing is all warped because of the curvature of the windshield. So yeah, we got to be careful with curved lenses or glass that we're looking through. And that's why, for me, I've basically had to just throw most of that stuff out because it's inconclusive at best. Because you look at one and it says, oh, well, there's a curve. And you look at another and it says, well, no, there's not a curve. You know, same altitude. Okay, so I mean, you've heard all the arguments with regarding fisheye lens and all that stuff. So I mean, visually, I'm not convinced by anything I've seen so far because it's either demonstrably shot with a fisheye lens and grossly distorted, showing concave and convex and flat. You know, it's all over the place, or it's just showing flat as a pancake. And I'll play this.
Sailing Directions, Planning Guide, and En Route, Antarctica, prepared and published by the National Geospatial Intelligence Agency, copyright the United States government. This is the 11th edition, the 2017 document. Let's see, we're going to go to page 54, and we're going to take a look at something interesting here. We're going to look under optical phenomena, and it says optical phenomena are common in the region to the south of the 50° south marker, and their frequency reaches a maximum in Antarctica. These phenomena, whose appearance range from intricate geometric patterns to colorful electrical displays, are associated with the refraction, reflection, or diffraction of light and electromagnetic activity. There is almost no dust or solid particles in the Antarctic air, and the prevailing winds blowing off the continent have small moisture content. Consequently, the visibility is usually very good and often exceptional, a fact which, if not appreciated, may lead the observer into serious error when judging distances. An object which may be thought to be but 5 miles distant could well be 30 miles away, and mountains have been sighted at 300 miles. Let's read that last sentence again. An object which may be thought to be but 5 miles distant could well be 30 miles away, and mountains have been sighted at 300 miles. Let me just say right here for the record that if anybody can see mountains 300 miles away, then the globe Earth is done, which we've said so many times. But you'll allow excuses. If you do allow those excuses, then expect them, because that's how they've gotten away with this for 60 years. Think about what's being said here. If we can see mountains at 300 miles in the distance, let's start out with the highest point on Antarctica. So we're giving them every credit we can possibly give them. They're at the highest point in Antarctica, which is 4,897 meters or 16,066 feet. So they're at the absolute highest point, and they're looking off in the distance to see 300 miles away. And when we punch that into the calculator, we get about 13,000 feet of hidden curvature. So they're already over 3 miles high, and again, if they're looking at any mountains 300 miles away, then they are all far too short to be seen. They have to be behind the curve. So this is where we run into problems, and it gets much worse, because that we just took at 16,066 feet. Let's bring it down and say they're on a boat. The name of the PDF, or the title of the PDF, was the Sailing Directions. So they've given some information for sailing directions saying that people seen mountains at 300 miles. So if that's true, then we really need to pay attention here, because what that means, let's put that into the curvature calculator. And what do you know, with 10 feet observer height, looking at 300 miles, you would have over 11 miles of curvature. Ladies and gentlemen, there is no mountains over 11 miles or anywhere close that are going to be seen in Antarctica from over 300 miles away, or 300 miles, or 250. We can see that that is 58,397 feet. Let's change it to 100 feet. It's a very large boat now. And when we do that, we get a total of 55,000, still 10 miles behind the curve. It's simply impossible and obvious what's going on here. I wanted to show you a website that you can go to. It's called beyondhorizons.eu. If you head over there, it's people who are taking pictures of extremely long distances. You need to do the same. Get out and do your own tests, do your own research, because when you do observe mountains at 120 miles, at 150 miles, 160 miles, then you have no more reason to believe in a globe. It's impossible. What you have to believe is you have to then take the words of men who say that for some unknown reason, the sun is lifting mountains up off into the distance from behind the curve, which has never been proven, which has never been shown. There's no test, there's no experiment that can show it. It's just men's words. That mountains get lifted up, and it's not like they float up in the sky, or sometimes they're a little bit wavy and they're distorted and it's a mirage. No, no, no. These are complete mountain chains sitting at the horizon. So while you may call flat earthers idiots and you may call them morons, it is not flat earthers that are believing in the levitation of mountains. In the 11-mile high, 55,000-foot levitation of entire mountain chains for the sole purpose of displaying them for you at the point of the horizon. No flat earther believes that. However, if you're a globe earther, that's what you believe. That's what you trust. That's what you've put your faith in, that that's what's going on. And when it comes to refraction, it doesn't even matter whether they need it to bend up or to bend down. They'll just say whatever they need to say at that particular moment. And another thing that I can't say enough is that you need to recognize why waiting for mainstream to come out with this, or waiting for the current science establishment to relinquish these facts, will never happen. Because they've built their entire scientific enterprise around these ideas that we are debunking, that we are calling into question. And so they cannot call them into question. They cannot go and double check their work. They cannot do the scientific method. At whatever point they decided to go forward with the ball Earth that doesn't match observations, that doesn't match our curvature measurements, that doesn't match our observations of mountains at 300 miles and 160 miles, and when they didn't change, even though there were signs that things were not correct, when they decided to go forward, because for whatever reason they didn't want to go backward, even though that is what science is, well, then that's on them. But it's our job then to step forward and say enough is enough, because we're just giving them the ability to say whatever they want and people just follow it. Even though people like myself and many other great researchers are pointing out all the evidence that tells you, that screams that we have all fallen for a mathematical construct, not a reality. There is no reality to space travel. There is no reality to moon travel. There is no reality to moonwalks. There's no reality to Stephen Branson putting hotels in space. There is no reality to Juno orbits around Jupiter. There's no reality or truth in the Pluto missions. There's no reality or truth in Cassini. They've never been to Venus. There certainly is no rover on Mars. And there absolutely is no Starman in a Tesla Roadster in outer space. And the quicker you can make that decision for yourself and do your own research and reach the right conclusion, the better. Or you can put your trust and faith in Brian Cox and Bill Nye and Michio Kaku, people who could not possibly even begin to look into the things that we're saying are not true, because it calls into question their entire industry. And believe me, they're going to do everything in their power to keep their positions of power, to keep their significance and their fame. The last thing those guys are interested in is the truth. And that
Let's interrupt the footage right here for a second and do a flyout in Google Earth. It's an approximate location along the flight path. Actually, we had crossed Colorado River. But anyway, this works to illustrate just the curvature of the Earth that we should be seeing. Have a look at how it looks, how the land just appeared from that horizon. You can definitely tell there's curvature due to the aspect ratio, and also a little bit of curvature in the transverse or x-axis direction. Very interesting. I have to scroll here quite a bit to get out to the mountains. This is Navajo Nation land. Here we go. And now we're approaching the 14,000 foot mountains of Colorado. Here's a map illustrating the flight path from Los Angeles. Along the flight path, we determine lines of bearing towards the mountains that I see in the distance. That's how I can tell what I'm seeing. Take special note of Humphrey's Peak. It's a great point of reference. If we were living on a globe, a sphere, the mountains in Colorado should not be visible. They're only 14,000 feet, and at that distance, the curvature would be hiding them. Flying at 30,000 feet, we should be looking down towards a tangential point to the sphere at about 3.1 degrees relative to our perceived horizon, or 90 degrees to the gravity vector. I was able to use in-flight theodolites to determine that that also is not correct, indicating the Earth is really flat. This graphic captures what I've learned so far from my infrared imaging from high altitude. The atmosphere prevents seeing at shallow angles. There's a critical angle beyond which the light rays just bend as they enter the warmer regions of the atmosphere with more moisture content. So we cannot see way in the distance. There is a limiting factor. As you can see in the inset, using my theodolite app, I determined where those angles were, and you can see that where the spherical Earth horizon, the theoretical, should be, we can obviously see above it. And at about 1.9 degrees, it seems like we can't see anymore because of the haze. But if we look at the surface that we're seeing, it doesn't curve out of view. If that were the horizon, it wouldn't look like that, We would be looking at a zero grazing angle. As you watch the video, keep these images in mind. I've extracted what the mountains look like along those lines of bearing we saw on the map. So be on the lookout for these. I will try to narrate and point them out. Initially, I did not see the mountains at 500 miles. I thought they were clouds. I only noticed them around 480 miles when I was looking at Humphrey's Peak. That's when I noticed those pale, what looked to me like clouds. And then later I noticed what they were. Now here's the shocking conclusion, folks. We're seeing those mountains in the distance at the correct elevation for a flat Earth. Just incredible. Not only should we not be seeing those mountains if we lived on a sphere, but we're seeing them, and we're seeing them at the correct elevation for the shallow observational angles, which are about 0.38 degrees to those distant mountains and about 0.9 to Humphrey's Peak. Simply incredible. The Earth appears to be astonishingly flat.
and then a glober teaches you something. It's not often, but it does happen. So a big thanks to Craig Brown, who left me this marvellous comment teaching me about Mount Taranaki. If Craig had never mentioned this, I probably wouldn't have come across, in my opinion, the best flat earth proof I have seen up to now. This is Mount Taranaki in New Zealand, and it can be viewed 230 kilometres away from Wellington on a good seeing day. Craig pointed me to this photo. Now this type of photo I've seen many times, and globers are hopeless at comprehending what they are seeing. When you do the analysis on this type of photo, you will find every time that it neither favours a globe or a flat earth. The math doesn't fit either model. Now, the globers will say if you have extreme refraction, it might favour a globe and vice versa for a flat earth. But if it doesn't fit either model, then there must be something else at play. For the flat earth researchers out there like myself, who do long-range observations over water, they will already know what I'm about to say. And that is that every time you observe long-distance objects over the ocean with your P900, you will see mirroring of the bottom part of the object. This happens every single time when filming over the ocean. Here is a clip I filmed from Dalyellup to Cape Naturalist Lighthouse, 55 kilometres away. Well, if you get severe mirroring at 55 kilometres over ocean, you know the mirroring over 230 kilometres will be there for sure. You simply cannot film long distances over the ocean and expect everything in the bottom part of the image to be crystal clear. It just doesn't work that way in reality. What we need is an infrared shot of Mount Taranaki from Wellington. Now that would really tell us what's going on. Well, guess what I found on YouTube? Mount Taranaki from Wellington using a P900 infrared camera, the same setup as my camera in the footage I showed before. Okay, so in my humble opinion, what you're about to see is the best flat earth proof I have seen to date. I know that's a big call, but the amount of missing curvature in the footage you're about to see is mind-boggling. You see, Craig's image is from 300 meters elevation, so the math doesn't really do anything for me. In the following footage, the elevation is 96 meters. Let's repeat that and let it sink in. The camera elevation is 96 meters, and the distance is 214 kilometers. That gives us 2,514 meters target hidden height. Hang on, what's the elevation of Mount Taranaki? 2,518 meters. Oops, hang on. So none of Mount Taranaki should be visible from 96 meters. Okay, roll the tape. Oh man, it must be a cloud shaped exactly like Mount Taranaki. What a coincidence. To spot the mirroring, look at the left-hand side where it looks like it goes straight down. That's a telltale sign of where the mirroring is starting. So under this line, we are simply seeing a mirroring of what's above the line. That is why you can't look at a photo like this and say everything at the base of the mountain has disappeared. You're just not going to get that level of detail at 214 kilometers away. So I guess it's game, set and match, and I may as well finish the video here. But wait, there's more, much more. You see, I've been tricking about the 96 meters elevation. Our photographer Paul has also done, wait for it, a 41 meter elevation, and again captured most of the mountain. Roll the tape. So at 210 kilometers away at a 41 meter elevation, 2,748 meters should be hidden. So the whole mountain, plus 230 meters, should be completely hidden from view. And notice the same amount of mountain is in view from both the 96 and the 41 meter elevations, just as the flat Earth would predict. So, can everyone give Craig Brown a huge big thank you for helping us find the best flat Earth proof to date? Thanks, Craig. You're the best.
Hello everyone, thanks for watching. We're zooming in on Malibu, California. I was out here in February with my infrared camera. What you're about to see is a time-lapse that I did looking towards the tip of Catalina as shown on this map, over 54 miles away. Have a look, simply incredible. There it is. You'll notice the ferry and a small escort boat moving. I'm gonna zoom in here. There you go. Do you see the ferry and a small boat ahead of it? This is incredible. You couldn't see this in the visible spectrum. So what does this mean, folks? Well, if you haven't heard, the Earth appears optically flat. That means if we assume straight line propagation, the curvature of the Earth seems to not be effective in hiding objects as we see in this graphic. So I took my time-lapse from about 150 feet elevation. The tangential point to the surface is 50 miles out. And then out to that tip of the island, about 38 miles. Well, if the Earth was curved, the surface should have dropped 960 feet below line of sight. Yet, we were able to see the ferry and a boat, which is, admittedly a little bit in front of the island, subtract 10 miles or so. Still, we shouldn't have been able to observe those ships. Anyway, that's the phenomena right there. Very fascinating. Anyway, hope you guys enjoyed it. Stay tuned for more because I have another amazing photo that I'll be posting shortly. Have a good one, folks. Thanks for watching. Welcome to Malibu, California. You're about to see the world with new eyes. The veil of haze and fog will be lifted, and you will behold the flat Earth like never before. But before that, let me show you how I got here, because it's been quite a journey. Back in January 2016, I clicked on my first Flat Earth YouTube video out of curiosity, and I was hooked. I bought a camera and headed to the beach. This was my first photo that got me thinking. I took pictures of distant islands from Santa Barbara and started doing calculations based on known reference points to see if they appear at the correct elevation. I've done a lot of imaging of oil rigs to see if the curvature of the Earth hides them at all. Lots of thinking over 2 years. I began to realize I need to see through fog and haze because at the coast it's usually hazy most of the time. I got into infrared photography. This is a 720 nanometer filter for my DSLR camera. and I was impressed. It seemed to work better than visible. I even headed out to different places to explore the flat earth. This was Salton Sea in California. The water was very calm and I could see very far. Then I went up north on a trip and I was in Idaho. And this is Lake Pandoray. And I was able to see a boat way in the distance. Slowly I began to realize that there is something to this flat earth movement. This is Lake Tahoe here, 18 miles across the water. And I could see the casinos. This was highly fascinating, but the next experiment really got me thinking. I was flying from Buffalo, New York to Chicago early in the morning, and there was glare over Lake Erie, and I could see way in the distance. I was testing out the notion that the horizon rises to eye level, and using a app on my phone that takes advantage of the inclinometers, I placed the crosshairs down at about negative 3.3 degrees, which is where the horizon should be from that high up in the air, yet I could clearly see the lake. This was really something else. I really got hooked on this flat earth. I set out to prove to myself that it's refraction. Refraction must be what is causing this flat earth phenomena. I started studying the mirage over water, and the closer I looked at it, the more disturbed and perplexed I got. Light seemed to be bending upwards, not downwards. Initially I thought the reflection is off the surface, but the surface is rough. It can't be off the surface. Then I started reading different papers and I realized there's a evaporative boundary layer. I began to realize that the shallower the observational angle is to the surface, the more prone it is to refraction in the evaporative boundary layer. Beyond a certain critical angle, there is a lot of bending of the light rays. That's why when the flat earth researcher looks out in the distance, the angle becomes shallower. Based on this new insight, I decided I need to sight objects over land and really tall objects like mountains, so the angle is somewhat steeper and I can minimize atmospheric refraction. And to see as far as possible, I started using infrared, which can pierce the fog and the haze. Now have a look at these videos. A gorgeous day in mountain. Let's see what we can see here. There's a light right there. There's a light. There's Santa Monica. Now have a look at the invisible world. It's a gorgeous day. I'm gonna go walking on this trail right here. Here we go. I'm in position and I'm pointing the way towards LA. And there you have it. That's LA with the San Gorgonio Mountains in the distance, over 100 miles away. Incredible. But wait, there is more. Look at that. That in the distance is the ghostly figure of Mount San Jacinto by Palm Springs. over 117 miles away. I'm panning to the right, and there's another mountain peak that's visible. There you go. That's the LAX control tower to the right. Just incredible. That peak is over 70 miles away. This is just incredible. Look at the difference infrared can make. It can reveal the unseen. The perfect tool for researching the flat Earth. Let's have a look at the map to see what we saw. There's 3 lines there, and those are the peaks that we were looking at. Very far away, incredibly far. But I wasn't pleased with the resolution, so I embarked on another project, a high-resolution imaging project. I bought a Celestron spotting scope and a monochrome astronomy camera, and I put an infrared filter in front of it, an 850 nanometer infrared filter, and it worked pretty good. Have a look at this. Look how I can zoom in on an area. That area in infrared was 3000 by 2000 pixels, high resolution, and I could zoom in. This was the island visible from Santa Barbara, but soon I went to Malibu again. Have a look. Wow, just look at that. Wow, behold your flat Earth, folks. Let that sink in. If this doesn't move you, perhaps math will move you. In the next slide, I'm going to show a scale. I finally had the resolution I needed, and I could create a scale based on one of the buildings in the foreground. So based on the building you see in the foreground 12 miles away, I now had the resolution I needed to see the floors, the different floors, and I averaged a few of them together, and I assumed about a 12-foot separation between the floors. And based on that, I created the scale in milliradian. And wouldn't you know it, that mountain not only is visible when it shouldn't, but it's showing up at the correct angular elevation. Simply amazing. Now, if the Earth was curved, we shouldn't see Mount San Jacinto, even though it is 10,600 feet high. The shoreline and the hills on the other side of the bay should be hiding it in entirety. Now, if we compare this to the flat surface model, look how simple it is, and it is accurate. We calculate the correct elevation of 17 milliradians. Simply incredible. Now I'm gonna leave you with these images. Just ponder under this, folks. This is incredible. That's all I can say. Incredible. Behold your flat earth, folks. Just incredible. This picture was taken from even farther away. I went to Point Dumay, 122 to the peak. The peaks to the right, 125, and even farther away. Just incredible. A ghostly image of distant mountains, bearing a silent witness that the earth is